Okay, good morning, my period 1 Algebra 2 class. I'm sorry that I'm not there with you today, but you have an assignment to work on in your homework packet, and I thought that maybe you would like me to help you get started with this. And so if you're having trouble getting started on this assignment, I'm going to do number 1A with you and then help you set up long division as well, just to help you get going. So here we go. If I'm looking at number 1 in my packet says to identify all zeros, x-intercepts, the degree, the local mins and maximums, and end behavior. So we have a lot of work to do. And in order to do this, you're definitely going to need your graphing calculator. So make sure that your graphing calculator is out and ready to go. Clear everything so that way we know that we are set to go for this assignment. So 1A, zeros. That should be pretty easy to identify the zeros. Our zeros are going to be any place where the graph hits the x-axis, and we have a total of 3 zeros. So we have a 0 at -5, 0. We have a 0 at 3, 0, and we have a 0 at 7, 0. Those are my 3 zeros. 0, done. The y-intercept, well, the y-intercept is actually labeled for you very nicely. The y-intercept is this point right here I'm going to have in green. The y-intercept is 0, 105, and we're going to need that to find our a value. The degree of this function, since it has 3 zeros, the degree will be third degree. Now, in order to find our local mins and local maxes, we're going to need a graph. But we don't have an equation yet for this function, so we're going to have to write an equation on our own in factored form. Since this function has 3 zeros, we can start out with y equals a times x minus r1 times x minus r2 times x minus r3. Those are my 3 zeros set up in factored form. And I've labeled out my zeros very nicely. They're -5, 3, and 7. So why don't we go ahead and plug those into there. -5 will become x plus 5. 3 will become x minus 3. And 7 will become x minus 7. We're almost done with factored form, but we need the a value. And in order to find the a value, we're actually going to use the y-intercept to help us find the a value. The y-intercept is 0, 105. So I'm going to start with 105 equals, that's the y value, a times 5 times -3 times -7. This is all stuff I've taught you how to do, and if you look back in your notes for this section, you will see in your notes, you will see the process for completing this. Multiply 5 times -3 times -7, you get a total of 105. And therefore, when you divide by 105, a equals 1. So my final factored form will be y equals 1 times x plus 5 times x minus 3 times x minus 7. Here is our equation for this particular function, for this polynomial. It's third degree. And we're going to use that equation right now to find our local mins, our local maxes. So let's go to our calculator. In your calculator, type in 1 times technical difficulty there. Here we go. 1 times x plus 5 times x minus 3 times x minus 7. We're going to graph this. I'm going to start with Zoom Standard. If I graph it, you can kind of see that I can't really see my local mins and maxes very well. But if you look at the original problem that I gave you, we can kind of pay attention to, just for a moment, take a look at the scale they gave me. Y goes up to positive 150 and down to negative 150. So that will help me out when defining my window. So I'm going to go back to my calculator and hit window. Go down and change your Y min to negative 150. Your Y max to positive 150. And now hit graph, and you can nicely see your max and your min. If you have to pause this video to get caught up or go back, please do so. We're ready to find our local max. Our local max. In order to find local max, you're going to hit the second key, the trace key, and scroll down or hit the number 4, and you get the little flashing bug. I want to find the max that's over here, so I'm going to move my bug over to the left for left bound for that max. Anywhere to the left. Hit enter on left bound. Now move your bug over to the right. Hit enter on right bound. Hit enter one more time, and your local max is negative 1.861 and 135.207. Take a minute to write that down right now on your answer sheet. I, of course, already forget. Negative 1.861. $135.207. Local max done. If you notice, there is only one local max on our graph. There's only one. Just this point right here is our local max. I now would like to find the local min. To find your local min, you're going to again go into second, trace, but this time choose option number 3, minimum. And we're going to have to move our bug over to get to the left-hand side of the minimum. So if you notice, I'm pushing my arrow over to get to the right-hand side or left-hand side of my min. Hit enter once, scroll over, hit enter twice, and then enter one more time. And there is your local minimum right there. This is my local min. And I want you to take a minute, record it on your answer sheet. 5.194 and negative 40.392. That's our local min. The last thing that we haven't found yet is our end behavior. So for our end behavior, we simply look at the left and the right hand ends. When I look for my end behavior, I want to look at the left and the right. Let's start with the left. On the left, the graph, if I put an arrow, goes downwards to negative infinity. And for the right, the graph points upwards to positive infinity. And that is the complete answer to this question. So you can see you have a lot of work to do on letters B and C. On letter B, when you do letter B, please don't forget in letter B, you will actually have 2 local min values. 2 local min values. But before you do that, you have to find the equation. If you want full credit for this assignment that I'll check tomorrow, I better see all parts written out very nicely just as I showed you. look back at your notes to do number 2, and I want to get you set up on long division on number 1 on the back of your homework sheet. For long division, you start with 3x minus 2 divided into 6x cubed plus 11x squared minus 19x plus 6. I'm going to get you started on the first few steps, and then I want you to finish it on your own. You're going to focus on this term right here. This is your all-star, this term. And your goal is to figure out, what do I multiply this term by to get 6x cubed? Stop and think about, what do you multiply 3x by in order to get 6x cubed? We multiply by 2x squared. So that way, when I take 2x squared and multiply it by 3x, I get 6x cubed. And when I take 2x squared times negative 2, I get negative 4x squared. You will now subtract. These had better cancel out, and they do. And 11 minus negative 4 is 15x squared. Bring down minus 19x plus 6. And now you're going to figure out, what do I multiply this 3x by in order to make it look like 15x squared? I'm going to leave the rest of this problem up to you to finish. Take it through to your final remainder. Finally, I would like you to do questions 2 and 3 with synthetic division. Do not forget, when you set up for synthetic division, inside the box, if you're dividing by x minus 4, you place a 4, and then write out your terms 3, negative 11, 7, and negative 44. Skip a line, draw a line. Go back to your notes to figure out how to finish that problem. Tomorrow, I'll show you how long division and synthetic division connect to finding imaginary roots. So I'll leave you with that little cliffhanger. Make sure that when I see you tomorrow, you have both of these pages completed with all the parts that I want. I modeled how to do some of them for you. You have an assignment now to finish on your own. Have a great evening. I'll see you tomorrow.